In this video, I'm going to go over how to create a router on a stick, which is, if you didn't know, a method to help different VLANs communicate with each other. So if you're confused about what VLANs are, an easy way to think about them as I do this exercise is as individual wires, logically. I mean, obviously they're connected to they're configured in a switch, but logically, the wires that go through a switch you can think of as being completely separate. And because they're separate wires, they can't communicate with each other unless they're connected by some medium, which for a router on a stick, we'll use a router to help the two wires with different networks on them, different VLANs on each end, communicate with each other. So to start off, we're going to have VLAN 10 and VLAN 20. This PC will be connected to VLAN 10, and this PC will be connected to VLAN 20. So let's start configuring things. We'll go into the switch, do enable conft. And first thing we want to do is just look at our first interface, which is FA01. So we'll go to int fast Ethernet 01. And what we're going to do is do switch port mode access. So that's basically just saying this port is going to be an access port. And then we'll say switch port access VLAN 10. So we're setting this line to be VLAN 10. This port is going to be VLAN 10. And then we're going to do the same. As you know, it creates VLAN 10 because VLAN 10 wasn't created yet. We're going to do the same for fast Ethernet 02. Except we're going to assign it to VLAN 20. Okay, so now we've created our VLANs, but we still have one more port remaining, which is fast Ethernet 03. This port is connected to the router, and both VLANs need to travel across it, which in that case, we need it to be a trunk port. So what we'll do is go to fast Ethernet 03, and we'll say switch port mode trunk, and then we have to say switch port trunk allowed, and we'll say VLAN 10 20 because we want to allow both VLANs 10 and 20 to travel across this trunk. And there we can go ahead and save our configuration on the switch. Okay, now we're moving on to the router. So for the router, with a router on a stick, your configuration builds off of sub-interfaces because we have both VLANs going into a single interface. So we have to create a sub-interface for each VLAN. But first, what we're going to do is go ahead and turn on our interface that is the gig 000. So we'll just say no shut. Okay, so then we'll go to interface. This is how we create a sub-interface. We can just do gig 000.10, and that will be a sub-interface for gig 000. And what we're going to do with the sub-interface is assign it an IP address. But the first thing we have to do before we can assign it an IP address is we have to encapsulate it with I spelled encapsulation. We have to do encapsulation with .1q, and this is important. The next number has to match our VLAN ID. So what we do is encapsulation .1q with the VLAN ID 10, because for this sub interface we want to assign it to 10. So click enter, and then we can assign an IP address. You can't assign the IP address until you have assigned encapsulated in .1q. So we'll assign the IP address, oops, and we also have to not forget about the subnet mask. And this is the IP address for the sub interface. Next, we'll do the same thing for our interface that is sub interface 0.0.0.20. Now the 0 after 20 does matter, so 20 is not the same thing as 2. Okay, and then we'll do encapsulation .1q20 to match our VLAN 20. And from here, what we're going to do is IP address 192.168.20.1 for the interface to be the address of our sub interface. And we'll press enter. And there you go. We have our interfaces lined up. Our sub interfaces are set up on the router. And now, if we go over to this PC, we can set up our actual IP addresses for the PC to match the network that corresponds with their VLAN. So here, this will be 192.168.10.2 and then we'll have the subnet mask, and we'll set our default gateway to 192.168.10.1. And we'll do similarly over here, 192.168.20.2, 192.168.20.1. So this default gateway is the address of the sub interfaces that we set up in the router. From here, this might not work the first time, but we'll try to ping, we're in PC1, which is this PC right here, and we'll try to ping 192.168.10.2. So there, the first time it didn't work, but after that, we actually got a reply. So as you can see, we're able to officially communicate across these VLANs. Even though they're different VLANs, we can use this router and its sub interfaces to treat each of the VLANs as a different interface, even though they're just connected through one trunk, and successfully communicate between the two VLANs. I hope you enjoyed this video and that you'll find it useful when creating a router on a stick yourself.